All right, welcome everyone. Let's get into introducing the FHIR Path Go Library and your speaker, Matthew Rodusek.
Hi everybody, thank you for joining my talk. I realize that it is 4:10, basically near the end of the day, so hopefully everybody's still awake. Today I have a pretty exciting talk, or at least exciting to me anyway. I'm going to be announcing an open source tool that we've released as part of Verily. So, to start off, I am Matthew Rodusek. I'm a technical lead at Verily Life Sciences. For anybody who's not familiar with what that company actually is, that used to actually be a Google X Moonshot project, so it's actually under the Alphabet umbrella that broke away into its own separate company. A little bit about me. I am a recovering C++ developer. About 10 years working with C++, it took friends having to tell me that I had a problem to finally get over it. And yeah, I'm getting my 2-year token in July. I'm a Rust enthusiast in my spare time. It's not actually relevant at all to this talk, but as a Rust developer, I need to tell other people that I'm a Rust developer. But most importantly, I'm actually a professional Go developer in my day-to-day job, which is what's relevant for this talk. And I am also the contributor and the lead for the FHIR Path Go library that I'm announcing today. So as a quick recap, I'm sure many of you have probably already seen some of this if you've gone to other talks at the conference today or this week, but I'm going to just quickly cover a bit of FHIR Path. It's not the main part of this, though. So what is FHIR Path? It's a traversal language, primarily to access different pieces of data or to query data from FHIR resources. It's an excellent way to actually read and access different pieces of data. It behaves kind of similar to the likes of XPath, if you're familiar with that with XML, or JSON Path with JSON, but it has a lot more richer functionality, things like functional access, and as well as environment variable support. Yeah, just that. It supports functional and numerical expressions. So how does it work? You get, everything is kind of a series of expressions, so kind of going from one expression into another. That also means that a single FHIR resource is actually an expression, like a collection of one resource. So there is no such thing as a single item, it's a single collection of one item. And so I have a quick example of like patient.name.where given is equal to Paul. And what this actually does is it limits the input to only patient types. It extracts the name field from the patient. It calls where, which is a function that does filtering, and it only does it if the result of the previous one, so name the given, if that given field is actually equal to Paul. So very simple functionality. And it has a bunch of different parts in the grammar that is very useful. You get empty collections, you get numbers, you get quantities, which are kind of like numbers with units associated to it. You get dates, you get date times, times and date times. You get equality, inequality, you get equivalence, which is very similar to equality, but with kind of a little bit more loose connections there. So things like case insensitivity or disregarding units. And then basic comparisons, Boolean expressions, all that fun stuff. And then functions, which is ultimately where it becomes a bit more powerful. So anyway, with that out of the way, why FHIR Path? And so ultimately, Verily actually has a lot invested in FHIR. Like, we're a healthcare company, so naturally we have a lot of FHIR. And additionally, with our roots from Google, we have a lot invested with Google Healthcare API. If anybody's actually used that, you might know that it's also written with Google FHIR protobufs, so protocol buffers. It's generated code that is able to be serialized easy over the wire for communication, and so that's kind of what you'd use to communicate with the Google Healthcare API. And so anyway, FHIR Path makes it easy to navigate through resources, and it's overall just an easy language to read and understand, and easy to embed, which allows for data driving your decisions. And so this part right here is actually really important. The embedding is one of the things that we actually make the most utility out of in Verily, and that's something I'm going to show a little bit later on. Because it's easy to read and easy to embed, you can actually have human-readable examples, which is great for writing things like integration tests, and things that are very easy to actually read and understand for compliance requirements. And oh yeah, surprisingly straightforward to implement. If you take a look at the specification, one of the cool things is it comes out with an ANTLR grammar. ANTLR is like a custom format, and you can actually just use that to generate the entire parse tree. So it's really straightforward to start off with, and then you're just kind of building different parts of the actual expression trees. One of the questions that comes up often is why we didn't actually just use an existing solution, because there are a number of libraries out there already, written in different languages, some including Go. And so ultimately, there's no mature solution that met our needs for Go. There are some out there. Not very much activity on it, so we didn't really have a lot to actually go off of with it. Like I mentioned earlier, we use a lot of Google Cloud Healthcare, and so we wanted something that made it easier to communicate with that, and some of them are actually either written in custom DSL or like use JSON. We're using a non-Go solution. Not really a good starter either, just because non-Go solutions require a binding layer. If you're familiar with Go at all, it becomes a little bit hard to actually compile and reuse some of this stuff, so it wasn't really the best direction to actually go in. No pun intended. And so yeah, the non-Go solutions also had varying support for the spec. If anybody's actually played around with the HL7 example FHIR Path implementation, you'll know that it's a lot more lax than some of the other existing implementations, for example. And so we did what any developers would do. We built our own, and we're open sourcing it. So on to the cool stuff. So what can we actually do? I'm going to get to an actual link, but it's under Verily source, FHIR Path Go. So it covers all the basics of the FHIR Path N1 grammar. That's a very formal way of saying it covers the base specification. So if you're not familiar, FHIR Path is broken into kind of two different parts. The N1 is the normative part of the grammar, which is like, it's kind of decoupled from FHIR itself. It's more about, well, actually it's about path navigation. It's about expression evaluation. It's about some of the function supports. So like provides all the very detailed and rich stuff, but it's largely removed from the actual FHIR implementation that you're using. So it's mostly not related to like R4 and stuff like that. But then we actually do cover the extension portion, which is under FHIR Path R4, which is the FHIR Path R4 resources, which connects to all the R4 stuff. And so that is where it actually starts to include the important things like polymorphism, evaluation across system and FHIR types, where FHIR Path defines things like a FHIR Path string, which is different than a FHIR string, and allows you to actually communicate between those. It also allows for some of the other kind of niceties, things like environment variables are part of the R4, or sorry, certain environment variables are part of the R4 specification, things like %resource, %root resource, just stuff like that. And then there's also just additional functions for just general usability. But ultimately, this is kind of the boring stuff. I'm actually going to show some examples. Oh, and one important disclaimer. We don't have full compliance of all the different functionality. We're still building it out. We do have a lot of the functionalities that make it like overall useful, many more than some of the examples we've already seen for other implementations, but we are still missing some. So what does actually make it stand out? Well, we support pre-compilation, which actually makes it a lot easier. A lot of implementations actually do the evaluation directly inline, which is kind of costly because then you're actually doing reparsing pretty much every time you run it. We have a regular expression type of interface. Some actually do this already, so we're not unique in this specifically. But this does actually allow it so that when you're doing evaluation, it's going pretty much once through the entire parse tree. And then you get also compilation errors separate from evaluation errors, which is cool as well. If you are using Cloud Healthcare, it works directly in terms of R4 protos, which is really, really useful because you don't have to be translating between different DSLs each time. You get configuration options that can allow you to alter your implementation, which is very useful for providing extension points, makes it really good for integration testing and stuff like that. I have some examples coming up on that as well. So you get custom function support. This is not technically something that is listed as an extension point in the FHIR Path specification, but it's not listed as one. So you can actually install and create custom functions, which is very, very useful if you want custom filtering, if you want to do other useful things. We have custom environment variable support. That one actually is a formal extension point. Again, I have examples of this coming up. The ability to replace time. So if you actually want to ensure that a FHIR Path specification that's or FHIR Path expression that is using like now will actually evaluate to now, the real time that you want in a test, you can actually do that quite easily. And then we also have in-progress work still being done for things like FHIR Patch. And this is another kind of separate substandard, if you're not familiar with it, which allows more mutations, where FHIR Path is more about expression evaluation, and for traversal, FHIR Patch lets you actually add things, remove things, and modify things. So, compile and evaluation time errors. Basic example, you have the ability to compile separately. Compilation lets you actually check individual errors so you can see whether your expression even was valid to begin with. And that's distinct from your evaluation ones, where your evaluation will actually check whether your data was correct when you're trying to do something. So maybe you're called a function with bad inputs or something like that. With custom function definitions, this is one of the really powerful things. With custom function definitions, this is one of the really powerful things. It lets you actually specify, it lets you actually work with defining your own custom filters. Because FHIR Path actually lets you, because each component of a FHIR Path expression is basically a collection of inputs as input, collection of resources and data as input, and that leads to the output, you can actually do your own filtering on this. And so this is really useful if you want configuration files with complex logic. I have a very trivial example here that only filters and evaluates to a Boolean value, checking whether it's one value. Terrible name, called the custom filter. But yeah, simple example. And so, powerful mechanism. It actually uses Go's runtime reflection to determine what the actual type is for the function. This is kind of cool because you can kind of write it like you would a normal function as you pass it in, and it makes it absolutely really easy to do. And of course, everything is statically validated because it's compiled. So custom environment variables, again, similar idea. You can define custom variables per evaluation. This is really useful because you can also use this to provide additional data throughout the entire thing. You can data drive test data in human readable kind of ways. So this is really useful if you want to have it for like event filtering. This is actually a real live example of what we do within Verily. With evaluation of environment variables, you can say that like an event resource, if you're trying to use this as a filter on updates for, say you want to read an event from Firestore. So this is kind of a really cool and simple approach that you can follow. And so this is actually a live example of something we have in, well, I call it live. I had to modify it for these slides. But so we have integration tests that are written in Cucumber. And so this is actually a kind of real world use where you can kind of tie all of these things together. You can actually say, I want to define custom environment variables, and then this on the back end would actually then provide that as options, as inputs into the next FHIR path that is evaluated. And then you can write human readable things. Like this is human readable to the average user, even if you're not yourself a Go developer. So this is actually a really powerful way to connect and bind things together. And then, of course, this one's a little bit more boring, but testing against time. If you actually have some tests and you want to make sure that the time that you have in the test is what you think it is from your test data, really good way. You can just kind of replace it as you go along. These are things that are not typically supported in an average implementation, but these are important if you want to follow good test hygiene. And so yeah, it lets you be aware of test time. And so we break things up into different options packages. We have compile options and evaluation options. And so evaluation options obviously are provided when you do evaluation, and compile is for compilation. And then one of the other interesting things is FHIR patch support. So FHIR patch is, again, the standard for mutations. We're not complete on this, but we are still adding more. So we have limited support for it. We currently support add, delete, and insert. So adding allows you to add into a place that does not currently have a field. Insert allows you to specify an index, and then deletion allows you to, well, delete the element at the resource. And so this is all kind of built in, all to the same FHIR Path library. Ooh. Oh yeah, and so future support is still planned for move and replace. We're rather pragmatic in the way that we're going forward on this, in that we like to try to choose only things that are currently in need, so we're kind of implementing as we go along. But, so one of the big questions you might have is, I don't use Google Cloud Healthcare, can I still use it? And the answer is, actually, yeah, you really can. So, because realistically, we're only using the protobuf representation, you don't really need Google Cloud Healthcare directly for this. So if you're using Go and you want access to it, all you really need to do is convert your, presuming you're coming from a FHIR JSON format, you just need to convert that to Protos. So you can actually use the JSON package to convert things over. You create your marshaller, convert it into the protobuf format, and away you go. The only thing that you might need to actually change is, the only thing that I don't like about this is a little bit more difficult than I would like it to be. So this, after these slides, I'd like to actually, or after this presentation, I'd like to actually go and modify this, because realistically, we can make this even easier. We should actually just have a basic like FHIR path from JSON type of implementation. So yeah, in summary, we aim to be compliant with all of the N1 specification. We have support for extended features of FHIR Path R4, direct interoperability with Google FHIR protobufs, easy to use with JSON, easy to extend for custom functions and environment variables, and we have more features implemented semi-regularly. Made in Go with love, because honestly, we all really enjoyed working on this. And we're supported by Verily. So yeah, seriously, go check it out. It's cool. If you want to connect, these are back.
We do have time for questions.
Hey, it's Nick from Google. I appreciate you building this. I'm wondering if you have thought about how you're going to version your library. Are you going to follow along with like patches to the normative, like N1 being the patches to your library, or are you going to like version your library independently of that?
That's actually a really good question. So, I mean, right now N1 is pretty much the only published one as far as I'm aware. I don't think N2 has been published yet. I think probably when the time comes, what we might actually do is break it apart into just separate directories, one for N1 validation, one for N2, because assuming those are actually completely independent, I know that for the extensions for like R4 and R5, that actually does change some of the baseline fundamentals. Like for example, R5 has integer 64, which is not part of R4, so we don't actually have 64-bit integers just yet. So that would actually be a change to the underlying data types, so we might actually have to change some of that in the future. But at which point that'd likely be a version 2 of the entire library, so that would actually change the Go module package. Oop.
At the risk of other people asking questions. So yeah, there is a new version of the FHIR Path spec that is in progress, so that there are some new additions like split, join, a handful of those. Have you tackled any of those yet?
Not yet, but I'm actually really happy to know that split and join are finally going to be part of that. That was actually something I was looking for in the spec just the other day, funny enough.
Yep, so if you go to the CI build, that those are in there, it's been updated, and so that there is going to be a new round of balloting on the FHIR Path spec itself, which has got those STU updates in it. So super happy that those are there. And yeah, love what you've done. And if you want to get it into the FHIR Path lab so that you can test from that too, I'd be keen to talk.
Cool, sounds good.
All right, I think that is it. Thank you, everyone.
Great.